Have you ever tried to run TornadoVM applications within the IDE, for example, within IntelliJ or NetBeans or Eclipse, and you get a bunch of errors? Well, in this video, I will explain why we get these errors, and I will explain how to fix it. So if you are curious, stay with me and let's do it. So let's assume that TornadoVM has already been installed in your machine and you want to use the TornadoVM APIs in your Java programs to accelerate sections of your Java programs. How do we do that? Well, if you are in Maven, the first thing to do is to import the dependencies. That is an easiest step. We go to the XML file and we go to the section that specifies the dependencies, and we have two dependencies to look at. One is for the actual API that gives us access to the task graph, task schedulers, etc., and another one for the matrix API. The version we specify is the version that we have installed in our machine. In my case, I have 1.01 dev version. By the way, if you are not sure, there is a command in Tornado called tornado-version, and here it is, 1.01 dev version. So depending on your, when you did the clone and you did install, you might have a different version over here. Another important consideration is the backends that you have installed. What I'm saying this is because of the next step. So if we don't do anything else, and then we go to our examples, I have one called Hello Tornado here, and I run it, I will see this error. So I was able to compile my Java program, meaning, compile my Maven, with Maven the application to generate the jar file, to produce a jar file. But when I run my application, I find this error. This is because there is a missing class in the runtime that we need to specify. How do we do this? Well, we need to specify in the launcher of the application a list of JVM options. How do we know these options? Well, to know this, we go back to our installation of Tornado. In my case, it's in this directory. And there is a command that will tell us all the Java flags that are required for Tornado to run. That option is called tornado -- print Java flags. Tornado print Java flags. And there we go. It's actually telling us which Java is using, by the way, my path, and a bunch of lists of Java options. It's using the server compiler, it's unlocking the JVM CI because it's connecting to Graal for the compiler part of Tornado. And we have another option to specify where the native library is. In this directory, you might find the shared libraries. For example, if you are running with OpenCL, that will be the shared library for OpenCL in order to discover, dispatch, and handle the application through the OpenCL runtime. For example, when going through the NVIDIA GPU or Intel CPU, Intel GPU, and so on. We have a flag to specify the model path of Tornado and a bunch of flags that specify how to load the APIs. So it's important to know which backend do we use, because if you reconfigure Tornado to use different backends, we have different flags to import. Just to keep in mind. In my case, I have it or I install it with the OpenCL only. So these are the flags. So I can copy these flags in order to import it for the launcher of my application. So let's go back to IntelliJ. And now what I have to do is to go to the configurations, edit my configuration for this application, and I'm gonna add the end options. And then in the VM options field, I'm gonna paste all the Java options that I copy from the Tornado configuration. If I click apply and I click run, now the application will run. So this application is not printing anything, but at this point we can start including options that are specific for Tornado that will tell us, for example, the device that was used, the amount of threads that were used, the kernels that are printed, and so on. Let's do that. Let's take, for example, the number of threads and the device that was used. We can do that by clicking again on Edit, configurations, and in the same field, in the Java VM options, we add another one called -d tornado thread info equal true. We call apply and we call run, and now we get some information. So it seems like we are running two kernels, two methods, and both of them were executed on the RTX 3070, which is the GPU I have on my system. And we have also other information, for example, the number of threads that were deployed on that GPU. In this case, it's 512 threads. We can easily map these two to the application. In this case, I have a task graph with two tasks. Each task points to a method. One is for initialization, the other one is for compute square. So I'm expecting to have two kernels, one for this and one for that one. So in this tutorial, I just want to show you how to run within IntelliJ. I'm preparing a set of tutorials in which I will explain the Tornado programming model in more detail. So stay tuned for that. So let's add another flag to print the generated code. So how Tornado works is that it will try to offload the Java methods to something else. For example, in the case of OpenCL, it will offload the Java method to OpenCL code and then will dispatch automatically the OpenCL code on the corresponding device. In this case, it's the embedded GPU. We can tell Tornado to emit for us the generated OpenCL code. That flag is called it can be invoked with -d tornado dot print kernel equal to true. If we call apply and run, now along with the thread information for each device or for each kernel, we will see the generated code. And that's what we see here. So for the initialization kernel, that's the OpenCL code, and for the compute square kernel from Java, that's the OpenCL code. And that's the way we interact or we run applications within IntelliJ using TornadoVM. All right, that was easy, right? Okay, so this concludes this video, this tutorial, and I'm preparing a set of new videos that will explain the TornadoVM programming model with some examples. So if this is something you are looking for and you are willing to learn, stay tuned. With that, happy coding and see you soon.